Okay, let's start off by reminding ourselves the graph of the exponential function. If you have y equals to 2 to the x, I've shown you that the graph looks like this, where what is this coordinate? 0, comma 1. So that's 0, comma 1. And then we can try to find the inverse function of this. Let's try to find the inverse function of this. So inverse would be, you set x as 2 to the y, right? How do you solve for y? You take log base 2, because then log base 2 and 2 will cancel. So you get y as log base 2 of x. Okay. So you see, log is the inverse function of the exponential function. That's what I was saying in the beginning of this logarithm section. You can kind of see that from this cancellation law. All right, now the question is, what is the graph of this? Well, if you think about it, the graph of this is obtained from the graph of this by switching x and y. So you have y and x, and you're switching, right? If you do that, what happens to the graph? It's like flipping over. Huh? No. It's rotation over what? Not x-axis, not y-axis. It's this. Yeah. Diagonal. How do you call the diagonal? Y equals x. So y equals to x is where this thing will rotate. So if you rotate this around the diagonal, which switches x to y, y to x, right? Since it was 1 here, when it rotates over, you're going to get a 1 here as well. Right? Something that does this, you're going to get something that does this. Okay? And then something that does this will be like this. Okay? Furthermore, the original e to the x, the original 2 to the x, has this horizontal line as an asymptote, because as you extend the graph to the left, it gets very close to the x-axis. Okay, it doesn't touch it; it gets very close, right? Therefore, if you rotate a horizontal line around a diagonal line, the horizontal line becomes, somebody already said it, vertical line. So what you get is this horizontal asymptote will become a vertical asymptote for this graph, okay? So the end result is that you have a graph that looks like the following. You have a graph that looks like this, where this point is 1 and you have this. And this is the shape of y equals to log base a of x for any a that's greater than 1, okay? As long as a is greater than 1, this will be the shape that you're going to witness, okay? Yeah. We also know that 1 will be the x-intercept, because if you plug in 1, log a of 1 is what? What's log a of 1? 0. We said 0, okay? Yeah. All right, log a of 1 is 0, right? So we know that 1 comma 0 is always a point on the graph if you have this equation, all right? Okay. So that's our graph. And then, all right, so let's try to draw that graph. And the key is to try figuring out the asymptotes and intercepts before you do it. And even before that, you want to try to find the domain. Okay. Oh, by the way, I forgot to talk about the domain here. If you look at the graph, you see that the graph only has something when x is positive, right? So from this picture, you can see that the domain of the log function is 0 to infinity. The domain is 0 to infinity. All right? So we're going to do the same thing here. I want to find out the domain. What's the domain? X plus 4 has to be greater than 0, so you subtract 4, so x is bigger than negative 4. Now, why would I want to know the domain? That's because, see, if you have the domain, that you kind of know where the vertical asymptote is. What's the vertical asymptote here? This is x equal to 0, right? And x equal to 0 is really the beginning part of the domain. This 0 and this 0 are the same thing. Okay, so if you know that, and you found out that the domain is from -4 to infinity, for this graph, where would be the vertical asymptote? Yeah, vertical asymptote will be x equals to -4. Okay? That's going to be our vertical asymptote. All good? All right. Next, we need to find out two intercepts, the x-intercept and the y-intercept. Let's start with the y-intercept. That's easier. How do you find the y-intercept? Set x equal to 0. Yeah. You don't want to put y as 0 because then you have to solve for y, but if y is already 0, there's nothing to solve. So that's not a good idea. If you want to solve for y, you have to set x as 0. So y-intercept, you plug in 0. So y is equal to negative log base 2 of 0 plus 4 plus 3, right? And that's going to give you negative log base 2 of 4 plus 3. But 4 is 2 squared, right? Okay, so what is this then? They cancel, and you have negative 2, right? So you have negative 2 plus 3 after canceling. That gives you 1. Okay. So you see that y-intercept is 1. Okay, next, how do you get the x-intercept? You set y as 0, right? You make it equal to 0, y as 0. See, to get x-intercept, you set y as 0 and solve for x. To get y-intercept, you set x as 0 and solve for y. That's basically the idea, always. So you have negative log 2 of x plus 4 plus 3. Now let's move this to the left side so that log base 2 of x plus 4 is equal to 3. Now you have to get rid of log base 2. How do you do that? Raise both sides by 2, cancels, and you get x plus 4 equal to, what's 2 to the third power? 8. So you subtract 4 both sides and you get x equals to 4. Okay, so now we found out quite a lot about this function. We know that at -4, this function will have a vertical asymptote. And because the domain is -4 to infinity, we know that the graph should reside on the right side of -4. If the domain was from -infinity to -4, then we would know that the graph should be on the left side. Okay? But since it's from -4 to infinity, the graph is over here. Furthermore, y-intercept is 1, so here's 1. X-intercept is +4, so here's 4. Right? And now you have to connect these two while having this as the vertical asymptote, right? So if it's like this, as you approach this, should you go up or down? Which one do you think is right? Should be up. Okay, because it was going up, it should continue to go up. Now, the real reason why it should go up is because of this negative sign. If you have a negative sign in front of the graph, what happens? The graph becomes upside down, right? So if you put a minus, the graph becomes like this. Okay, maybe I should put a different color. So this here would be the graph of y equals to negative log a of x, right? So if you have a negative in front, the shape of the graph should be this one, right? So that's why you know that the graph should be like this. Okay. And that's it. That's the only kind of graph that would have this as the vertical asymptote, these two as the intercepts. Okay. All right, that's all for today.